Advent of Code 2024, day 4. Let's put on our hat and get started. Okay. Yeah, today. So it's Sarah's search. Looks like the chief's not here. Next, one of the historians pulls out the device and pushes the only button on it. After a brief flash, you recognize the interior of the Saris monitoring station. Looks like that is a callback to 2019, day 10. As the search for the chief continues, a small elf who lives in the station tugs on your shirt. She'd like to know if you could help her with a word search, your puzzle input. She only has to find one word, Christmas or Xmas. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. It's a little unusual, though, as you don't merely need to find one instance, you need to find all of them. Here are a few ways Xmas might appear, where irrelevant characters have been replaced with dot. Okay, so we have dot dot x, xmas, xmas, a xmas, Xmas. Okay, cool. That makes sense. The actual word search will be full of letters instead. So for example, like this. In this word search, Xmas occurs a total of 18 times. Here's the same word search again, but where letters are not involved and any Xmas have been replaced with dots. Okay. Take a look at the little elf's word search. How many times does Xmas appear? To begin, get your puzzle input. Holy cow. All right, let's get started. So that's our input for this one. I'm going to pull up my repo. I'm going to create a new folder called 4. I'm going to create a new file. That was not what I wanted. Called input.txt. Paste. Create a new file called main.ts. I'm going to open up 3. I'm going to grab 3 and just paste it right here. We'll clean some stuff up since we don't need all of these. We'll have a part 1, we'll have a part 2. So let's gut it like this. And then we still have our decoder, our input, and then we're getting our contents. So I think we're good there. So, okay, how to approach this one? So we essentially want to, just like a word search, you're looking for certain letters and then you're going in a direction that is approved to find the next letter. And if that letter works, then you want to go to the next one and then the next one and then the next one until you find the thing you're looking for. So, okay, let's think through this. So we have a target word, which is Xmas. Xmas, it's capital, isn't it? So we're getting our input, which is just a string. So let's get, we basically want to convert that giant string into a 2D array. So lines is equal to input dot split. Okay. Const grid is equal to lines dot map. Line dot split and split on every character. Okay, so I feel like that's going to give us the grid, which is good. We can get the number of rows. Grid.length. We can get the I was going to say columns. I'm going to assume that it's a perfect grid and it's not, you know, some rows have 4 columns, some rows have 5. I think that's a safe assumption, at least for now. That might bite me, but we'll find out. So we can get the number of rows, the number of columns, and then we essentially, again, we're getting a count of something, so we need to total it. So, how do we want to approach this? Okay, let's make a function outside of here is it's match. It's matching the text. So is match is valid match. We'll just call it is match. We're gonna get a couple different things. So we're gonna get the row, which is a number. We're gonna get the column, which is a number. What else do we need? We're gonna get essentially another. It's like the next row, the next column. Those names aren't very good, but we'll manage. And then we need to iterate through those, right? So, excuse me. So we would do something like for let I is equal to 0, while I is less than, well, really we want xmas.length I plus plus. Oops, that is a comma, not a semicolon. Let's fix that. Okay, so now we have an iterator. So we'll be iterating basically one letter at a time, which means that we would have, so we're going through them. We need the current row, it's not really next row. I'm going to go with desired row, target row. Let's go with target row. That'll help me reason with this a little bit more. So we have our row, our column, target row, target number. Okay. So we're here. Let's get our next row, which is going to be row plus target row times I think. And then we'll get our next column. And that's going to be column plus target column times I. Oh, Lord. Okay, big conditional, I think. So we would have if next row is less than 0 or next column. Oh, wait. Yeah. If next row is less than 0 or next column is less than 0 or next row is greater than or equal to the number of rows. Okay, we're gonna have to pass that in. But we'll do the same here with or next column is greater than or equal to the number of columns. We'll just call it calls. That's what we called it in the part 1. Okay, or grid next row, next column is not equal to target I. Massive conditional. I think that's okay. What is target here? I've got target row. I don't have a target. So target row would just be xmas sub I. Okay. If that's the case, then it's false. It's not valid. Otherwise, if we get all the way to the end, then it's valid. So we have our isMatch. We need to add some stuff. So I'm just going to add row count is a number. Call count is a number. Target is a string. So xmas here becomes target. This becomes target. shoot, I need the whole freaking grid too, don't I? That being said, I can just pass in the grid and instead get the row count, rows and columns. Const row count is equal to grid dot length. Const call count is equal to grid 0 dot length. Okay, that makes sense. So we'll paste call count there. We'll paste row count here. Oh, oops, that's next column, not NC. And then we need to give a type to our grid. So this is going to be an array of string. Okay. Feeling decent about that. Let's come back to part one and let's plug that in. So we have this function that's going to match on things. So we need to iterate through all the rows, all the columns, and then essentially check a like if it's back one, forward, like a series of directions that are valid moves, because we have a subset of possible moves that are considered valid. So we'll take that approach. So let's just start with the loops. So we have for let, we'll just say r for rows is less than r dot rows, r plus plus. What did I do? Oh, that's a comma. I was like, what did I do wrong there? That was tripping me up for a second. Okay, so we have our rows. Let's do columns as well. C is less than calls. C++. Dangerous language. Okay, so now we have the tricky part. So we essentially want to iterate through all of the possible directions. So I'm going to do another for. We don't need to mutate these. For const of directions. What do we need? Like a yeah, okay, we do need to destructure from this, so we're gonna need like a directional row, so like a row change and a column change. And then we'll do if is match. We'll use our function that we just created, and we need we need grid target. So we need a row, we need a column, we need a target row and a target column. So this would be row change and column change in this case. So if these are valid matches, count plus plus. I think we're good there just with that. And then we'll want to return count. Okay, this seems, I mean, this is abysmally nasty, but honestly, this doesn't seem too bad outside of that piece. We do need to define directions. So I'm just going to define a constant out here called valid directions. Actually, directions is a good name. Valid movements sounds even better. So let's go with that. So we have valid movements, and then we essentially can move. So we have one to the right. So that would be a column change, but not a row change. So 0, 1. So that would be right. We could go down, which would be 1, 0. We could go up, which is -1, 0. And then we could go left, which is 0, -1. So that gives us our cardinal directions. We need our diagonals too. So I think that's just going to be a combination of all of these. So we can do a 1, 1, which is going to be to the down right. We can do a 1, -1 for down left. We could do a -1, -1, and that would be up left. And then we could do a -1, 1, and that would be upright. I think that makes sense. So we should have 1, 2, 3, 4, 5, 6, 7, 8. We should have 8 horizontal, vertical, diagonal, which would be 8. And it could even be written backwards, which we're good there. We're handling the backwards cases. Okay, cool. I feel pretty good about that. This is called valid movements, not valid moments. It's not a Hallmark movie. It's a set of instructions. Okay. I feel like we should run it. I'm going to use this first. So let's copy this and replace our input text with this, save it, and we should get 18. If we get 18, that is a good sign. Deno run, oh wait, sorry. CD 2024 for Deno run main.ts, 18? 18, holy cow. Okay, that's a great sign. Sure, let's see what we get. 2496 is my number. Let's paste it in, see if we get it correct. I have doubts, but I'm hopeful. Hey, okay, cool. No need to debug or troubleshoot. That's great. The elf looks quizzically at you. Did you misunderstand the assignment? I may have. Looking for the instructions, you flip over the word search to find that this isn't actually an Xmas puzzle. It's an X mass puzzle, in which you're supposed to find 2 masses in the shape of an X. Oh, Lord. Okay. Okay, so we can reuse most of part 1 here, but we're essentially going to need to, when we find a mass instead of an X mass, we just need to see if there's an intersecting mass. So we still need some of this. So I'm going to go ahead. Actually, I think we'll basically want all of this. Our isMatch function just may change a little bit. So I'm going to change this from isMatch to isXmass. And we'll define a new function up here called isXmass. It's going to have the same signature as this one, so I'm just going to copy and paste that, and we'll just update it. So isXmass. Okay, so we get a grid, we get a target, we get a row and a column. Okay, so we essentially have some patterns that we're going to be working with. So our valid movements become more strict. So I'm actually going to take this and paste valid movements at the top of part 1. And then part of the reason why is that we're going to need to move. Part of the reason why is that we're going to need to move our movement checking for this one, I think, into this isXmas function. So we're going to change some of these as well. In fact, this is going to be an array of arrays, because we can catalog the 2 different types of movements we have, which is a forward Xmas and a backwards Xmas, I think. So if we take this approach, we have an O, -1, and an M. Oh, this is getting to be a weird type. O1S. Okay, that makes sense. -1, 0, A. Okay, and then -1, -2, S. 1, 0, A. Oh no, what have I done? My types are all messed up. My arrays are too deep. Let's fix that really quick before I get lost. 1, 2, 3. Okay, that looks correct. So, and then we have 1, 0, A. And then we have 1, 2, M. 1, 2, M. 1. Okay, so M, S, A, S, A, M, MOS, I think those are correct. So we can copy this and then we can paste this down here, and then we'll adjust this for the inverse. So this would be 1, 2, S. This would be 1, 0, A. That one stays the same. This would be 1, -1, -2, M. This one would stay the same because it's an A. This one would be O, 1, M. This one would be O, 1, S. It makes sense to me. We would just inverse it to handle the backwards mass instead of the forwards mass. Oh, Lord. You know what? Give me just a second. I'm going to draw this out, and it may help me think through this. I will be back in just a second. Okay, yeah, I think this is correct, and I think this is going to work out. So what we need to do now that we have our valid movements are we want to return valid movements, and we essentially want to find some valid movements. So we have a movement here. And what do we want to do with this movement? We essentially want to make sure that every item in that movement is valid. So what we can do here is do something like movement dot every, and then we're going to have to destructure something. So what do we want to destructure? This would essentially be next row. This would be next column. And then this would be the letter, I guess, that we need to support. That seems reasonable. Oh, man. Okay, so we're checking that every case here is true. So let's just take all of this right here and paste it here. There's no way it's going to be that straightforward, right? So it'd be, oh, I guess this technically isn't the next one. It would be the, it's like the movement row. And then this would be like the movement column. And then I think we just need the, so it would be the row plus the movement row, and this would be the column plus the movement column. The type on this is actually a little weird. So if I do number string, we good? Oh, no, because that's not the valid type. It's actually an array of number string tuples of an array of numbered strings. Okay, number, that looks correct. And then we're not checking the target anymore, right? We're just checking the letter. I think let's simplify this too. We just want to return this value. We don't need to return false here in this case. But these are going to switch, right? We essentially want to make sure that if we're returning this, we're checking that these are truthy. So I want to make sure that the next row and next column are greater than 0. That also means that these are going to need to become ands. Actually, all of these are going to need to become ands. So let's do that right quick. Oh, that syntax error. That was a function definition starting instead of a numeric comparison. Okay, so, and then this needs to be checking equality, not checking inequality. So we have next row is greater than 0. We have next column is greater than 0, which makes sense. But we also want to make sure that we're in the bounds. So next row needs to be less than row count. Next column needs to be less than column count. Okay, that seems to make sense to me. So we're checking. Okay, that seems correct. I need to return that there. I don't think we need any of this anymore, so let's cut that. Looks like we don't need our target anymore. We don't need our target row and our target column because they're kind of inferred in here. So now that we have part 2, let's simplify the last stretch, right? So we don't need this word anymore. We'll clean up more as we go. But we have a row and a column. I think the interesting thing here is because we're essentially starting from the center of the word and working our way backwards or forwards. We don't need to start at 0 because you're never going to run into a scenario where it bleeds off the edge. That's assuming you can't wrap. It didn't say anything about wrapping, so I'm just going to assume that that's valid, that constraint is valid, that you can't wrap. So instead of setting this at 0, we can set it at 1. Tiny little optimization here. And then we also don't need to go all the way to the end, so we can remove one from the row count and the column count. Same with the column. Since we can't wrap, it will never be the first column. And it will never be the last column because we can't wrap. So we'll increase these by 1, just like we've been doing. And then basically the movement checking has been moved into this is Xmas function here. So I think all I need to do is a conditional that says if this is Xmas, we have our row, we have our column. Yep, okay. Count plus plus. Oh, we need our grid. We have to pass in the grid because it's something that we have declared that we need to pass in. Let's give it a shot. 10. I have doubts, but let's paste it and see what we get. Yeah, that's not the right answer. Okay, cool. Okay, let's take a look and see what I have done wrong. So we're passing in the grid. I think we're good on the part 2 function. There's not a ton going on. So I think the issue is in our Xmas function here. So let's see, we get the row count, we get the column count. So that looks valid. We have our valid movements here. MSA, SAM, that looks good. 2, 2, 0, 0, -2, -2, 0, 0, 1, 1, -1, -1. That looks good. This should be 0, 0, 0, 0, -1, -1, 1, 1. Okay, those look good. So that's good. So I'm guessing I have an issue somewhere here. So we have our valid movements. We're checking some. So we get a movement. Let's simplify this. That's not needed. Just one less parenthesis to worry about. I guess technically that's not needed. Simplify this further. I'm just going to format this. Yeah, okay, much better. Okay, so we are checking if some of these are valid, and then we check every movement that is available from the pattern. So we have our row, we have our column, and then we have our letter. So we get our next row, which is going to be our row plus our movement row. That makes sense. Our next column, which is our column plus our movement column. Also makes sense. And we just need to do some checks, right? So we're checking that the next row is greater than or equal to 0. Checking that the next column is greater than or equal to 0. We're checking that the next row is less than the row count. Okay, that makes sense. Yep. And then we're checking that the next column is less than the column count. So greater than or equal to 0. Next column is less than the column count. Okay, that would be my issue. For the letter M, I accidentally did a less than symbol. I have been hitting typos like crazy on this keyboard lately. No idea why. That's probably our issue. So let's give it another go. Okay, we got 27 this time. That seems a little more reasonable. So let's take that number. We'll paste it in here and see if that is still not the right answer. Okay, so unfortunately, I did not get the correct answer. I am at time for, well, all the time I have for today to do this puzzle. So I might continue working on today's. I might skip it. I don't know. We'll see. See where the day takes me. But hopefully this was helpful. I'll push up everything I have so you can kind of see where I'm at with this, even if it's not correct. And, you know, we can take things from there. But, you know, before I do that, This is not correct. That way no one copies this and flames me on Twitter because I didn't solve their advent of code for them. Okay, commit this day 4. Push that up. Okay, and again, github.com/bradseipert/advent, and you'll be able to access this code and all the code from previous days as well. Hopefully this was helpful, that we really kind of knocked out the first part pretty quickly, and then it got a little complicated, and I'm struggling to kind of think through that fully. So maybe with a little bit more time, I will be able to come up with a better solution. But I don't have the time today, so we'll see where that takes me. Hopefully you have the time and have better luck. Have a good one. I am back. I went to a coffee shop, as I usually do on Wednesdays, to work on an open source project of mine. And thankfully I did work on that project too, but I also had this problem just grinding at me, so I decided to fix it. So I took another approach, and I really like this approach too. It's simpler. It's not fancy. It doesn't feel cool or really neat or anything interesting. It's really rudimentary actually, but this is an Xmas function. We're just changing the body of it. The signature stays the same. So I changed it. So I'm looking at the row and column that gets passed in. I just care if it's an A. So if this is an A, then I'm just grabbing, you can kind of see here, I'm grabbing what's in the upper right, the upper left, the lower left, and the lower right. I'm grabbing those right here. I have 2 variables here, right to left and left to right. Those are set to false. I look at the combination of characters for upper right and lower left, and if either of them are M and S or S and M, respectively, then I set that to true. I do the same thing here for left to right, and then I just return the union of these 2 booleans, so they both need to be true. Otherwise, I return false. And yeah, so if we run this again, we get a different value. I've tossed my input file. So much stuff going on. Advent of code. 2 stars. So yeah, we're good. But if I grab my input here, paste this into input.text, go back to this, and then we run it again, which we will do right here. For Deno run main.ts, yes, 1967, which happens to be the correct value that we need. So yeah, sorry I didn't record me actually solving this. I solved it at the coffee shop, but I figured I would at least give you a full solution. So hopefully this was helpful. Best of luck with day 4, and looking forward to seeing you again tomorrow for day 5.